Hello everyone, and this is Devabrata, and welcome you to our channel Schrödinger's Cat. In our previous lecture, we have discussed the topic ensembles in statistical mechanics in the chapter of thermodynamics and statistical physics, and basically today we just discuss here the particle physics in the topic the nuclear and the particle physics. And basically here in the exams point of view, we just summarize the topic and solve problem in CSIR NET and GATE, and after we get some time and we discuss elaborately the theory for the better concepts and give you 5 problems. So here in the GATE exam there are approximate 5 to 6 questions are coming in the nuclear and particle physics, and for CSIR NET 3 to 4 and TIFR 1 to 2, GEST also 2 to 3, and the particle physics most about 1 or 2 questions are come in the exam point of view. Basically today we will discuss the classification of elementary particle, the leptons, baryons and mesons, particle and antiparticles, elementary particles, quantum numbers, and the classification of fundamental forces, Gilman and Neumann's classification system for hadrons, Quark model of hadrons. So first of all, we just discuss the classification of the particles. We just summarize here the topics. So classification of particles, so you just know the elementary particles here, elementary particles, so it have 3 sections. So one is photon, second one leptons, and third one is the hadrons. And for lepton there are some particle like electron, neutrino, the muon, neutrino, and the tauon, neutrino, and the hadron. We have basically 2 parts here. One is meson, the another one is baryons. So for mesons there are pions, pi plus minus 0, kaons, k plus minus 0, and the eta mesons. And the baryon we have 2 part. One is nucleons, the another one is the hyperons. So for nucleons it have 2 particles, the protons and the neutrino, and for the hyperons it have lambda, sigma, psi, xi, this one symbol, and the fourth one is omega. So these are the classifications. So next we shall discuss the particles and the antiparticles. So basically first of all that the electron and the positron, so electron proton and antiproton, p plus p minus, so pi plus pi negative, pi positive, pi negative, pi naught. Neutron and antineutrino is n negative 2, p negative, positive plus nu e, and another one is neutrino and antineutrino. So elementary particles, quantum numbers, another topic, elementary particles quantum number. So first of one is for the charge. So basically for charge q should be 0 and the plus minus e, and the spins for bosons, that the integral spin 0, 1, 2, and for the fermions the half integral spin half c by 2 dot, and the another one that the baryon numbers, so this is the spin and the baryon numbers, that is b, so plus 1 is for baryons, the minus 1 is for antibaryons, and the 0 for the others. So next one is the lepton numbers. Lepton number is Le, L mu and L tau. Basically the Le is positive 1. This is for the electron and electron neutrino. L mu is equal to plus 1 is for the muon and the muon neutrino. L tau is equal to plus 1 is for the tauon and the tauon neutrino, and the minus 1 is for corresponding antiparticle and the 0 for the others. So next one is the strengthness number. Basically that the is defined as S strengthness number is plus 1 for kaons, minus 1 for hyperons, minus 1 for lambda hyperons, minus 2 for xi hyperons, psi hyperons, minus 3 for omega hyperons, and we have y equal to s plus b, 10s number and the baryon number, and q is equal to I3 is basically isospin quantum number, and the third or z component of the spin is b plus s by 2. For weak interaction, for weak interactions, that del s is equal to 0 or plus minus 1, The next thing is that the hypercharge is basically define y. So y equal to 2 q bar, or q bar equal to y by 2, and we know y equal to b plus s, so q would become I3 plus y by 2. The next one is isospin or isotopic spin is defined as the I, basically the multiplet number m equal to 2i plus 1, where I is equal to m minus 1 by 2, and the m is the multiplet number, and the I magnitude is equal to root over I into I plus 1. I is isotopic quantum number, and the I3 is the component along z axis. And for integral, its range I minus 1, 0, minus of I minus 1, minus I. And for half integral, this would I minus 1, minus half, half, positive half, minus of I minus 1, minus I. This is for the half integral. And the last one is the parity. Basically the parity minus 1 whole to the power L, just as the angular momentum J to the power P, where P is the parity. Next, go ahead. Our next discussions for the classification of fundamental forces. So we have just 4 forces. First one is the strong force. Particle associate the hadrons, and the range is this is force. Just a minute. This is basically force, and this is particle associate, particle affected, and this is the range. This is the relative strength, and this is the particle exchanged. So basically, for the strong force, here the range is 10 to the power minus 15 meter, strength 1, and this is the meson is spin 0. Second one is the electromagnetic force. This is basically the charged particle, and the range is infinity, and strength 10 to the power minus 2. This is for the photon, spin 1. Third one is weak force for the hadrons and leptons, and the range 10 to the power minus 17 meter, and the relative strength minus 13, and this is the interacting bosons, spin 1. Fourth one is gravitational. gravitational force, all particles. Infinity range, strength 10 to the power minus 40, and this is for the gravitons, spin 2. And the next topic is that basically, so quantum number that are conserved in the interactions, this is very important for your exam purposes. The quantum number conserved interactions, this is important for your exam purposes. So first one is charge, second one is spin, third one is baryon number, fourth one is lepton number, basically L mu, L tau, and the quantum number that are conserved in the interactions. Quantum number that are conserved in the interactions. So basically here, strong interactions, strong interaction. So for strong interaction, del S equal to 0, del I is equal to 0, and third component of isospin is equal to 0. For electromagnetic interactions, del S should be 0, del I should not be 0, and del I3 is equal to 0. This is important for MCQ. Third one is weak interaction, and for the weak interactions, the del S should not 0, del I should not be 0, and also del I3, third component of isospin, should not be 0. This is very important for your exam purposes. Third one is the Gilman-Nizimi relations. Charge is equal to third component of isospin plus half of baryon number plus strengthness number. This is the Gilman-Nizimi relation. So go ahead. Our next discussions, that the kinematics of the high energy collision relativistic. So we have some formula here. The threshold energy T1 is m final square minus m initial square by 2m2, and the threshold energy expression should become q 2m2 minus m1 plus m2 divided by m2. And for the non-relativistic collision where q less than mi or m2, that ETH would become minus q m1 plus m2 by m2, non-relativistic collision. And second one is for the extremely relative case. So for extremely relative case, the ETH threshold energy would become q square by 2m2. So another thing is that the quark model, this is the up quark, down quark and S, and their antiparticle UR, DUR, anti-quark S bar. And another thing is that the charm bottom and top. So charm, the charge is plus 230, strengthness number 0, and the charm quantum number Qn should be plus 1, and for top plus 230 and the bottom minus 130. You just do all the relation by the Gilmanism. Charge is equal to, I should write here, 1/3 plus half B plus S by this formula. You all find this term. And second, another thing that the Mason and Baryon octet, Mason and Baryon octet diagram. So in this diagram you just find the spin number and the Q value and the particle associated with, like K naught, K positive, pi negative, here pi positive, this one, and this one, this one, and this one. So you just find this eta naught, pi naught, this is K naught bar, and you just find this octet by the formula general, the interactions between the equations here, and this equation you just try to find. And another one is the, for the Baryon octet, you just find and draw this octet diagram here, this for the Baryon octet, and so this one, and so this is for the N P, sigma negative, sigma positive, and psi naught, and this one is, this point is sigma 0 or lambda 0, and basically the Baryon octet, and this for the Mason octet. So these are the fundamentals, and we now just go through some problems coming in CSIR NET and GATE exams. So basically, first of all, for our problem solving sessions, first one is coming in CSIR NET exam in June 2018. Is saying that which one of the following elementary particle processes does not conserve strengthness. So basically, for doing this, you just to keep in mind the conservation of quantum number. We just write 2 is very important, the quantum number that are conserved in all the interaction, and another one, the quantum number that are conserved in interaction. Two things is very important, that the charge, spin, Baryon number, lepton number 1, and second one is the for strong interaction del S, del I, and del I3. Basically the selection rule here for transition particle to a particle and antiparticle, basically. So basically here, so first of all, we just try for the first equation that gives pi naught plus p to k plus lambda naught. So here first for the charge, so for charge that 0 0 plus 1 minus 1 conserved, the baryon number 0 0, this for +1 and -1, it should be conserved. And one thing is that this is for conserved for option A. First of one is conserved for option A. This is A conserved, B should be conserved, and for this C here, we just one thing is that this is not applied here, and basically for the option C, lambda naught to pi naught plus eta, here the S means spin, this should be the elementary particle, so spin we should just, these are associated with the spin, so we just spin for the third options is 0 0 0, so del S should be 0 conserved. Del S should be 0 conserved, and for the option D, this is k naught +1 and the 0 and the 0, so del S not equal to 0, this is unconserved. So option D would be our correct, not conserved here, option D would be our correct, and this is associated with the spin, so for spin del S is equal to 0, del I is equal to 0, and del I3 is equal to 0 for the strong interaction. And here we just do spin as well as the strangeness here given in the question. Strangeness, so this is numeric value for the strangeness number, S number. So second one is coming in CSIR NET December. Which of the following process is not allowed by the strong interaction but it is allowed by the weak interaction? This is important, strong and weak. So first one we just write for the strong interaction, we just write in your theory strong interaction del S del I del I3 should be 0. So our first summary of the topic or theory, this is very important, and for weak del S should not equal to, del I should not equal to, del I3 should not equal to 0. This is concept we just write in our summary sections after, before going to the problem. So you just, one thing is that we solve all the problems according to our summary formulas, and you see in your problems are coming in this topic, so you just keep in mind all the formula, and the summary section is very important of all the topic for clear NET and GATE exam. So basically here we just choose option 1 for trial, that the k naught plus pi naught to k naught antiparticle plus pi positive plus pi negative. So here we just find strong not but allow the weak. So here for the charge you just see 0 0 0, this for +1, this for -1. You just find the k naught particle, pi naught, all the numbers of charge, isospin, third component, baryon and the lepton number. So basically this is for the conserved. And for the I, isospin quantum number, this is for half, 1 for pi naught particle, k naught bar particle half, pi positive particle 1 and 1. This should be the conserved. and the I3 third component or Z component of the isospin, this is for the minus half for pi naught particle 0, for k naught antiparticle positive, pi positive particle this is 1 and this is minus 1. So here is that I3 del I3 is equal to 1, and one thing is that for I you just calculate half plus 1 and here half plus 1 plus 1, so this is basically not conserved or unconserved. And one thing for the strangeness number is that the 0 0 0 0 0, so this is conserved. So one thing is that one is spin and one is strangeness number. You just SP means spin and S for strangeness number, and this is for the spin SP. You should not be very careful for these two terms. So SP means spin and S for the strangeness number, and this is for S. So plus 1 and here for 0, for k naught antiparticle minus 1, for pi positive particle 0, pi negative 0, this is for the conserved, and del S is equal to 1. So you just, one thing is that here del S is not equal to 0 and del I3 is not equal to 0. So A option is correct, that is allow weak interactions. Basically this is not equal to 0 and not allow the strong interaction. So A option will be our correct answers. Go ahead, our next coming in CSIR net also. A baryon X decays by strong interactions. X to sigma positive plus pi negative and the pi naught, where sigma positive is a member of the isotriplet sigma positive, sigma naught and sigma negative. So third component of I3 of the isospin of X is what? So basically this X is equal to sigma positive plus pi negative plus pi naught, and the third component of isospin I3 is here, that for the sigma positive 1, pi negative minus 1 and the pi naught is 0. So basically I3 for the X should also 0. So our option 1 should be the correct. 0, X is 0, third component of isospin. Go ahead, our next, that coming in GATE exam 2019 is saying that long energy collisions, it is coming in collision sections. S wave scattering of pion pi positive and the deuteron D results in the production of two protons. Basically pion pi positive plus deuteron to 2 proton P plus P. The relative orbital angular momentum in the unit of H cross of the resulting 2 proton system for this reaction is what? So basically here the parity, we just, one thing is that the parity P is equal to minus 1 whole to the power L. So here the parity minus 1 into positive 1, and here this for 1, this is for the parity, this is for the parity minus 1 and the plus 1, and here the minus 1 to the power L pi P and the pi P, 2 protons. So basically now minus 1 to the power L pi P and the pi P should minus 1, just conserve. So we just get pi p is equal to plus 1. So minus 1 to the power L parity is equal to minus 1. So L should be basically the orbital angular momentum is the 1. So our orbital angular momentum of two proton systems here would be 1. B would be our correct answers. So one thing is that I think you just keep in mind quickly the quantum number that are conserved in the interactions for the charge, spin, strengthness number, baryon number, lepton number, and second one for the strong interaction del S, del I and the del I3, weak interactions and the electromagnetic interactions. These two is very important for the equations, and you just equal to both sides. Initial equation is equal to final equation, and you just go through all the problem. Last one coming in GATE, the elementary particle psi naught is placed in the baryon decouplet shown below. At x-axis the her component of isospin I3 and here the strengthness number. So basically we have the decouplet form of the Xi particles, that this is for the del negative, this one, this one, this one, this one and this one, and this is for the del naught, del positive, del double positive, sigma negative, sigma positive, sigma positive, psi negative, Xi naught and the omega negative. So our options here, Xi naught basically this one. So compare this, R would be our correct answer, C. So R would be the Xi naught here. So we have solved 5 important problem coming in CSIR NET and GATE, and for your better concepts and the understanding, we just get to solve you the 5 more questions here. You just pause the video and take a screenshot quickly. First 3 is coming in NET and second 2 is coming in GATE exam. You just solve and send me to my mail ID. Basically we just solve here the 5 and 5, the total 10 number of questions in a particle physics, and after one we just complete all the topics. We just elaborately do the theory and problem session of per topic 100 problems. Math physics 100, quantum mechanics 100, electromagnetic theory 100 problems, and I think you just take a screenshot of these problems, and finally as usual that you just do this 5 in your homework and send me with this mail ID. You all just know my contact mail ID is cat.schrodingers@gmail.com. So basically cat.schrodingers@gmail.com. in this mail ID you just send me all the solving problems. So last but not the least, thank you very much for listening to these lectures. I think it is very helpful and needful, and very curious for your exam purposes, GATE and NET exam also. Thank you, stay happy, goodbye, take care.